So we've done the basic sine graph and the basic tan graph. So if I just go sine of x, correct? Our sine graph went through 0, 0, did it not? Now I'm going to go zoom 7 and change it back to that standard window just so the ticks aren't so far apart, aren't so little. Okay, now I'm going to change my mode to a degree so it's even a little bit easier for you to see. And now I have to go zoom 7 again, so it changes my window to a degree window. If not, it wouldn't have drawn it well, right? Because it was in a radian window. So I have my sine graph. We agree. What's the amplitude of our sine graph? Basic sine graph. 1, because it's half the distance from the min to the max. What's the period of a basic sine graph? 360 or 2 pi, depending on if it's in degrees or radians. We agree? What's the midline, the line that cuts the graph in half on a basic sine graph? 0, the y-axis, right? Because what we do is we count our amplitude down 1, up 1, and they meet at 0. We agree? Okay, in y2, just paying attention, you don't have to do this in your own calculators, I'm going to put in cos x. So the red one is cos. We agree? What's the amplitude of a cos graph? Still the same, right? 1. What's the period of a cos graph? 360 or 2 pi, stayed the same. What's the d value of a cos graph? What's that midline? The line that cuts the graph in half horizontally, or vertically, sorry. Same, it's 0. What's the only difference between blue and red? One starts at the max, and one has its midline running at the y, right? So, is there any way that I can make the red be the blue or the blue be the red? What would I do? Horizontal translation, which we call what? Horizontal phase shift in this unit. Exactly. So we have to figure out what the heck the ticks are, right? What each tick is. Because technically, this blue one is a left shift away to be the red one, correct? What is the blue one? The blue one's the which graph? Sine. So this, no, stop. Oh, goodness. Okay. So I don't know what's going to happen. We may not have pens, but that's okay. So this blue one is a left shift away to be on the red one, right? But what is the left shift? Well, we need to figure out what this tick is, and then we'll know how much. How can we figure out what that tick is? On my calculator. In my window, it's the what? In my window, it's the scale, right? I'm going to go to mode. It's not even in degrees. It's still in radians. I'm going to go to degrees. I'm going to hit enter. And then I'm going to go zoom. So if I press graph, what's going to happen? Bad things. Because I have it in degree mode, but I have my window in radian mode, which is an issue, correct? So instead of crying, we could try, for last-ditch effort, zoom 7, and it'll change my window to what mode I'm in, at the very least. But if my minimum is at 10, you're not going to see it on here, right? So it'll change it to a window now that's in degree mode, but you may still not see nothing. In this case, we do. So we press window. Our X scale is what? 90. So every tick is 90. So this blue tick, or the blue graph, is 90 to the, if I move it 90 to the left, it'll be on the red, right? So the blue one, if I move it 90, blue one is the sine graph, 90 to the left. So I'm going to go to my y equals, and I need to move it 90 to the left. So I'm going to do what? I need to move it 90 to the left. Oh, that's 91. Don't know why I did that. Okay, then we're going to press graph. There's the blue one. There's the red one. Yeah. Giver, what's up? So I'm going to clear out this one, and I'm going to put it back. Sine x. And I'm going to press graph. I'm back to this. So I moved the sine graph onto the cos by moving 90 to the left. We agree? How could I move the red one, the cos graph, to be on the sine, the blue? 90 to the right. I'm moving the cos graph 90 to the right, correct? So I'm going to go x what? So what have we learned from this? We've learned that our amplitude, whether it's cos or sine, are the same, right? It doesn't change. What about the period of the graph, whether it's cos or sine? That doesn't change. What about the midline, whether it's cos or sine? That doesn't change. What's the only thing that changes, whether it's cos or sine? What makes it a cos graph or a sine graph? The horizontal phase shift. So the only thing that changes is your C. We agree? So let's go to the graphs that I gave you. This is the first one. If I get my A is based on my what? Amplitude. My B is based on my what? My period. Is the period the B, the period, are they equal? Can we interchange them? Never. So if you have the B value off your equation and the answer to the question of what is the period is one of the B values, you would just cross it off and you would have 3 out of 4 left, right? Because B is not P, P is not B. They're not the same thing. Your D value, your midline, is the line that cuts the graph in half, correct? So we're going to find all 3 of those first because they're the exact same whether it's a cos or a sine graph. Okay. So my amplitude. Why? It's 1, but why? Yeah, so it's the distance from minimum to the maximum divided by 2. So if I go from my min to my max, it's 2 divided by 2 is 1. So if I count down at 1 and I count up 1, they should meet. We agree? Where do they meet at? The midline. I have my D. What's my D? Right? So once you have your amplitude, D is really easy to find. You count it down, count it up. Where they meet is D. If they don't meet, you messed up your amplitude. You agree? The B value, we can't just say the B value is this. Because we can't just pull a B value off a graph. But what helps us get the B value? The period, yes, and 2 pi. So B equals 2 pi divided by the period, or 360 divided by the period. We agree? When do we know if that B is 1? Remember, what is B in transformations? What is B representative in your transformation? Your horizontal stretch. What is your sine and cosine graph always? If it has been stretched, your period of your sine and cosine graph. 2 pi. So if your period is still 2 pi, do you have a horizontal stretch? What would your B always be then? 1. If your period is larger than 2 pi, then you're going to actually have a smaller B, right? Because the horizontal stretch flips. Agree? Okay. Why did I do 2 pi and not 360? Because you're in radian mode. The only time you use 360 is if along that x-axis, which is your x values, there's degree symbols. Is there degree symbols in this case? No. So it's 2 pi. Okay. How long does it take to repeat itself? So I'm going to start here. Could I go from max to max? Could I go from min to min? Would those be helpful in this instance? Your weird ticks, would that be helpful? No. You can go from different things, but sometimes other places are better. So I'm going to do this. So I'm going to start at the y-axis and go past to min, past to max, back to that same height. Where does it happen at? 2 pi. Did it stretch? What's my B going to be? No, 1. Because it's not the period, right? Oh, no, B. 2 pi divided by 2 pi is 1, proving it is 1. But we don't even have to do that. We know that if the period is 2 pi, our B is 1, because it hasn't changed. It hasn't stretched, because our B is our horizontal stretch. We agree? So we have A, technically. We have B, and we have D. Our amplitude is 1. Our amplitude is always positive. Is our A always positive? No, off an equation, we always say take the absolute value of A to get your amplitude, because amplitude is always positive. We agree? So our A could actually be positive or negative 1. Okay? So we're going to get 4 equations from this graph that we could possibly have. 4 different equations that we could possibly have. So we're going to write them out. So we could have y equals, what's our a? Positive 1, what's our a? Also could be sine, sine. But what else could I have? Cos, cos. So that's why you get 4. Now, some people will say, how do I know which one I need to do? Well, first off, there will be, if it's a multiple choice, only one answer that's correct. So you could actually have to file through all of them, right? Or they could say, find the equation of the graph in y equals a cos b x minus c plus d, where a is less than 0. So they're telling you a has to be negative. Or they could say a is greater than 0. So they're telling you it has to be a cos graph, a has to be negative, or a has to be positive. That's how they narrow it down, right? Right now, we're going to do all of them because we want to be able to do all of them because we don't know which one they're going to give us. Okay, what's our b? 1. For every single one, correct? What's our c? Our c is the hard part because that's the part that changes for everything. We agree? So I'm going to leave it blank for now. And what's our d? 0. Do I have to put plus 0 at the back of all of these? No. Did I actually have to put 1s in front of all of these? The only place I needed the signs mainly, but that's it, right? Does it hurt to have them? You could just put a negative sign, not even the 1. Yeah. But I'm leaving them to prove a point. Okay? Okay. Pencils down. Paying attention. We're going to do cos first because cos is the easiest. You may not believe me, but it is. So we're going to go y equals, we're going to clear these out. And I'm just going to put a cos graph in. You don't have to type these in. You know how to type cos x into your calculator, okay? This is not that point. The point is you're going to tell me what is particular about a cos graph. So everything down, pencils down, paying attention so I don't lose you, so you're not just trying to do something on your calculator. Okay, this is the cos graph. This is a positive cos graph. We agree? What does a negative do in front of the cos? It's a reflection in the what? X-axis. So if I put a negative 1 in, I'm going to put it in a different color because I want pink. There we go. Negative cos x. I'm going to have a reflection. So it looks exactly the same, but it's reflected. We agree? Let's look at the y-axis because the y-axis is important to us. Because if we can make the y-axis replicate what's happened, we can figure out how far it's shifted. Okay? So on the y-axis of the positive cos graph, the positive cos graph is the blue one. What is on the y-axis of the positive cos graph? The maximum. This is correct. So if our maximum is not on the y-axis, our graph is shifted, has it not? Let's think about it. If we horizontally stretch the y-axis, so what's on the y-axis? It would be at, that one's at 0 and 1. We agree? If we horizontally stretch, we're multiplying. If we multiply by 0, what happens? Nothing. Stays the same. So does a horizontal stretch move it to the right, to the left? No. Does a vertical stretch move it to the right, to the left? No. Does a vertical translation move it to the right, to the left? What's the only thing that's going to move that max off the y-axis? The horizontal phase shift is going to move it off, which is our C value. We agree. So if our maximum, that's what we're going to look. So if it's a positive cos graph, we're going to look how far our maximum is off that y-axis. If our maximum is not off the y-axis, there's been no C value. There's no phase shift. If our maximum is off that y-axis, the graph has moved. Has it not? Okay, let's look. Is our maximum on it? No. Our maximum is actually to the what? Right or left? It's to the left. So I know at the very minimum, because I'm going to look for my max to get my C value here. I know at the very minimum this is going to be x plus C. Why? Because it moved to the left. It was on the y-axis, it is now to the left. Okay, how far is it to the left? It's tricky. I don't even know. It looks like 2 ticks. Okay, we'll go with 2. Good. 2 ticks. What the heck is the 2 ticks on here? How do we figure out how much each tick is worth? I've told this to you guys before. How do we figure out what the ticks are worth? The scale. The scale on your calculator, but we don't have one. So how are we going to... You count it? You count it to what? Closer? To pi. Remember I told you guys we go to pi. If we go to pi and we count how many ticks there are to pi, every tick is just pi divided by that value, the number of ticks. We agree? 2 pi is harder because it's bigger. Why wouldn't you go to 1? Pi is like 1, is it not? So if I go to pi, how many ticks, guys, does it take me to get to pi? 12. So what's every tick worth? Pi divided by 12 will give me the first tick, right? Because it's a pi divided by 12 ticks. So pi over 12 is a fraction, but it's also pi divided by 12. Is it not? A little division sign and a fraction is just division sign, right? So each of these ticks is pi divided by 12. So the first one is pi divided by 12, negative pi divided by 12. What would tick 2 be? Right, what would it be before you do that, though? Yeah. So every tick is worth pi over 12, right? Remember when I labeled them all as we went along? So this is going to be negative pi over 12, negative 2 pi over 12, negative 3 pi over 12, negative 4 pi over 12, negative 12 pi over 12. It's just pi. We'll reduce them. Then 13 pi over 12, 14 pi over 12, 15 pi over 12, 15, 16, onwards, right? They're always going to be over 12. But they don't always look like they're over 12 because we reduce the fractions. We agree? So this one, you're right, is negative 2 pi over 12, but it reduces to negative pi over 6. So we're actually going to add pi over 6. Why don't we subtract pi over 6? All of that. I'm sure it was right. Okay, so what we're going to do, though, is we want to know, the great thing about this is, there's sad things. Sad things, if you don't remember how to do it, you can't get the equation. Great things about this is we can check it. Can we not? Go to our y equals, and we're going to type it in. So I'm going to clear these ones out. And what was my equation? Positive 1, because we picked the maximum, right? Positive cos 1. Do we need these ones? No, but I'm putting them in because I have them. X plus what? Pi over 6 is a what? I was like when I asked this because I know where I'm going with it, but yes, fraction. It is a radian as well. It's like an open-ended question that only I know the answer of what I'm going for. So it's pi over 6. It's a fraction. If it's a fraction, what do we always have to do? Brackets, because our calculator doesn't know it's a fraction unless we put it in brackets, because that's the only way it knows. So we're going to go bracket pi divided by 6 bracket. So I close that bracket for that bracket. And I close the bracket for the other bracket. And I close the bracket for the other bracket. And then I can go plus 0. Do I have to put plus 0? No. Now, if you press graph, you're like, it worked. However, what did I tell you to do always in order to make sure that it's actually accurate? It looks like it possibly worked. I don't know. Is it shifted off? What do you need to do? What is your window on there? First off, your window is not the window that's on your screen, on the screen, right? The only way you can compare is if you compare exactly the same things, correct? Are we comparing right now? My calculator's in degree mode, first off. That entire graph's in radian. It's not the same, right? So we're going to go window, and we're going to make our window be that. But now if I go change my window to radian mode, I've changed my mode to radian mode. Okay, window. What was the lowest it went to? I know it goes a little further, but let's just use the last tick for easiness sake. Negative 5 pi over 2. Why did I not have to put that one in brackets? Because it's by itself. If I had anything else with it, I'd have to put it in brackets. Okay, and then it goes up to 5 pi over 2, I think. And what were each of my ticks worth? Pi over 12, because there was 12 ticks to pi. I took pi and I divided it by 12 ticks. What's my max? Am I min? Oopsies. And scale? Wow, now it actually looks exactly like the one you have in front of your face. So if you don't change your window to be the exact window like I told you guys to do every single time, right? You might think it's wrong just solely due to the fact the window's wonky. Here we can literally hold our picture right below our calculator and we can say, yep, they match. I know the ours goes a little bit longer, but they're the same thing. We agree? Okay, going back. Negative cos. Do you remember what the negative cos graph looked like? It's reflected. Look at this. Negative cos x. What's on the x-axis, or y-axis, sorry? The minimum this time. So for the positive cos graph, we look for how far the maximum moved. We agree? For the negative cos graph, we're going to look how far the minimum moved. That's it. Okay. And you usually look for the closest minimum. Okay? So I'm going to pick this one because it's closest to the y-axis. And I think it's at about 10 ticks. 10 ticks out of what? What is this? Out of 12. So 10 out of 12 is just 10 over 12? It's 10 pi over 12. Which reduces to 5 pi over 6, because I can take a 2 out. Now, where was it originally on the cos graph? Where was that minimum originally? On a normal cos graph? 0, on the y-axis. Is it on the y-axis? No, so there's a phase shift. Did it move to the right, or did it move to the left off of the y-axis? It moved to the right, so what are we going to do? Yeah. We agree? So, when it's a positive cos, we look for how far the max is, closest max. How far the min is, closest min. Sine is where I lose you. I don't want to lose you. I don't want to, like, I don't know, put you on TV, find you or something somewhere. I don't want to lose you. So, put your pencils down. This is where I lose half the class at all times. People listen? I know, I feel like I have power. Yeah, okay. I think everyone just wanted to drop the pencils. Okay, we're paying attention completely. We're not typing anything into our calculators. We're paying full attention here. So, if I put in the sine graph now, because cos graph, positive A, we look for the closest max. Negative A, we look for closest min. Does everyone understand that? Okay, let's put in a sine graph now. No, not let's us. Just take, yeah. Sine x. You agree? Okay. Whenever I'm doing horizontal phase shift of a sine graph, I have to draw the median line, the midline, the median value. Okay? So it's 0 in this case. We agree. And I'm going to go zoom 7 so I have a window back. Okay? Do you see where the midline intersects with the graph? Where do they intersect at? More so, where do they, for horizontal issues, where do they intersect at? On the x-axis is good, but horizontally I need to look at the y-axis. Okay, so do you see the midline in this graph? Do you see they intersect here? No, come on, join me. Well, it's just going to do, oh, weird, crazy. Okay, you see that little arrow? The intersection is on the y-axis. So I draw the midline of my graph, okay? And then I figure out where my closest intersections with the midline are. We agree? We see this? If the intersection, do you see how it's going upwards? If I go from left to right, my slope is up, which means positive. If I look for where my midline and the graph cross, positive slope, right here. We agree? It should be on the y-axis if there's no phase shift. If there is a phase shift, it's going to be somewhere else. So let's look at the graph. For example, draw my midline here. My midline is at 0. So my two closest intersections are this one here and this one here, pretending that that was actually drawn on the x-axis, which it's not. Okay, let's pretend it's really good. It's not, it sucks, but we will pretend it's really good. Okay, so this is our closest intersection, and this is our closest intersection, like where they intersect with the midline. So if I didn't draw the midline, you're going to try and find intersections. Usually we'll try and intersect them with the x-axis. Is the midline always on the x-axis? No. So we need to draw the midline, find our two closest intersections if we're looking for sine. We agree? Positive sine, the slope was going what? Up. Which one of these, if I draw from left to right, which is what I always do on graphs, is going up? Is that on the y-axis? Is that little red dot on the y-axis? The positive sine graph moved. Ah. What tick is it? How many ticks away? I can't tell. I really made mine fuzzy. It's 8. So it's going to be at 8 pi over 12, which reduces to, except negative, negative 2 pi over, close. You're taking a 4 out of both, guys. 12 divided by 4 is 3. Ooh, basic math we're down on, but the other stuff we're good. And throw you guys some crazy graphs, you can come up with an equation, but fractions, not going to happen. Okay, so it has been moved what? It should have been on the y. It is not. It's actually to the left. So what am I going to put? On the positive or the negative sign? Because it's going up. So we're going to go plus because it's to the left, 2 pi over 3. What do you suppose the other intersection point is going to be for? The negative. Why would that be? 1 second. When you reflect it, it changes the direction of the slope on it. So now it's going down on the negative. Okay? So let's go back. So what tick is this one? Can you guys look on yours? How many ticks away from y is that one? 4? So 4 pi over 12, which reduces to, I'm a little scared after the last one, pi over 3. Okay, we're on the y-axis. We're moving to the, nope, it's just not happening. Okay, it's to the what? To the right, so we're going to write negative. Okay, we now have 4 equations. If we typed all 4 of them in, what should we get? That graph. Really. It's nice having the fancy calculators because you actually see the different colors overlapping each other. What I find is that some people will think they have all the same graph, but you actually have like 4 different ones. You have one that you see, and then you have some roaming up here and down here outside of your screen, but because you only see one, you're like, they're all there. Watch it draw, like it will draw itself over, right? Remember, if you don't have the different colored graphs, that's fine. You can go to the left. Oh, I can't on this one. You can go to the left and you pick thicker, right? So you can have one draw thin, then one draw thicker, and then try the other ones and see, right? You can do thin and thicker. Remember I showed you that? Yeah, I did. Go to the very far left. There's a slash line, Tyson. Hit enter, and it turns to a thicker one. I love when that's new to you, but that's not, yeah, okay. Oh, you weren't here. When I taught this before, I said, don't try them all out, but you are. Okay. Let's look at this one. Okay, we're going to look at this graph. What stays the same on all four of the graphs? The amplitude, the A value, the B value, and the midline. What changes? The C. So let's get all the things that don't change. So my amplitude. The definition of amplitude is half the distance from the min to the max. So if I find my distance and I divide it by 2, I have my amplitude. What is it? Count it out. The distance. Distance means negative, means nothing. There's a distance of 10. So it's 5. Yeah. Ten divided by 2 is 5. But our A values are not our amplitude. Our A values can be positive or negative. It's not 11, it's 10.
What is happening?
Yeah. There's not 11. No. Sorry, bud. Okay. Yeah, yours is just different than everyone else's. I actually made yours a little bit different just to mess with you. Okay. Yeah. Oh, oh, yeah, no. Okay. This is not 1. 1, 2, if you're stepping on the graph. Okay. We need the midline. The midline's really easy once you have the amplitude. Why? It's the middle. So if you draw your amplitude down, you draw your amplitude up, they should meet at the midline. So we're going to go down 5. We're going to go up 5, and they meet at y equals -2. So my midline is y equals -2. So my d value is -2. Can my d be +2 then? Just because like amplitude's opposite, and it's like a is ±2. So can my d be ±2? Oh, a is ±5. It's not even 2 at all. D is where the midline occurs. The midline occurs at -2, not +2. It's not an option. It's just where it happens. Yeah. Now, the period of the graph is what? How long does this one take to repeat itself? No. We're going to go with 6. Yeah, we're going to go with 6 for ease. Now, on the diploma, if it's like you're guessing, you won't be guessing. There's no such thing as guessing. People look at these questions really well. So they'll either draw the line up so that you know for sure it's at that exact value, or they will actually give you the coordinate. So you know what it is. You're never going to be like, I think it's 6.5. Like, they won't do that to you. Okay? So the period is 6. So my B value is 6. And I move on. No, it's not. I'm glad there were some scared faces. Okay, the period and the B value are not equal. The period helps you get the B value helps get the period, but they do not, like they're like besties, but they're not the same. Your best friend is not you. You guys join, you help each other, but you're not the same thing. Okay, so how do I get the period? Or boom, 6. How do I get B? 2 pi over, why 2 pi, not 360 degrees? There, on where? On the x-axis. If there's no degrees on the x-axis, you use radians. Okay, so 2 pi divided by 6, so it's at pi thirds. So I have my B, I have my D, I have my A. Let's roll. Okay. So y equals +5. Y equals -5. Y equals +5. Y equals -5. sine, sine, cos, cos. What goes next? Pi over 3. I don't know what you guys are saying. Pi over 3. Pi over 3. Pi over 3. Then what? Then the x in there. Or wonderful, whichever way you want to think about it. I choose the latter. Okay. We don't know what goes in those. No. And what's the d? -2. Okay. If I have a choice, I'm going to do cos. If someone's giving me a choice, it's an open-ended written response, and I can give you whatever equation I want. I'm doing cos because I can look for the max and the min. I would actually do sine in this case for another reason, but you guys won't do that. Do cos, okay? So let's go to the closest maximum. What does the closest maximum give me? 1.5, I think. Okay? So the closest max is about 1.5. What does that help me with? That's great. I have the horizontal movement of that maximum. What does it give me? Nope. Your shift from the y of which equation? The positive cos, right? So I'm moving 1.5 to the right on my positive cos, so I'm going to be, well, it's supposed to be on the y. It starts on the y, so I moved it to the right. Yeah. Because you are moving from where you started. It doesn't matter. They'd be more specific. We really were like 1.5. So they would give you. Now this minimum is at 1.5 as well, but -1.5. What does the minimum help me for? Bless you. Negative cos. I moved to the what from the y? To the left. So what am I going to put? Are these always the same, 1.5 and -1.5? No, it just happened. Yay, but it doesn't change. Now, I told you, to get the horizontal phase shift of the sine graph, I need to draw the what? The midline. So I just draw it every single time anyways. Boom, it's there already. Okay. So you have to draw the midline. We have the midline. Then we look for where what happens. The midline intersects with the with the actual graph, right? Just where it intersects with the graph. Okay. So here is where it crosses, and where's the other closest? What will he say here? Why do I need two? Why do I need two places where it crosses? You have to look for slope up, slope down, slope up, positive sign, slope down, slope up for you, positive sign, slope down, negative sign, right? And you're going from left to right. So, what's this? Positive. Wait, it's on the y. It's good, we're done. So I would actually pick a positive sine graph because there's no horizontal shift. But Crystal in grade 12 would have totally picked cos because it's way easier to just find the max and the min. I would feel. You're doing where the midline intersects with the graph. So it's this one and this one. Because I'm doing positive sine. It's where it's going up, right? So could I put +0? Sure. Would they put +0? No, they just put x. You could even put -0. You could be a rebel. Okay. Now, that one's down. Downward slope. So where that one intersects gives me the horizontal shift of the what? Negative. Where does it intersect? At 3? At 3? 3 to the what? So what am I going to put? Just that simple. Nice. Okay. I'm giving you homework. There's 3 questions where you have to do the equations of the graph as sine. 3 questions where you have to do the equations of the graph as cos. So you should thank me because I didn't make you do 4 for each. And by I didn't make you, the textbook didn't make you, so I'm not making you. Now, no. So, 15 and 16. So there are literally 6 questions to do that you could possibly complete in class so that you can do the 70,000 questions that Tyson just said that I assigned yesterday. 70,000. Yes. Yes. How do you have to do all 4? Because you have to, shh, quiet please. The reason why you have to be able to do all 4 is because they could give you the answer to any of these 4 as a multiple choice and you need to know how to do it. If you only knew how to do 1, but the answer they gave correct was the cos negative, which one of these is the equation to the graph? Yeah.